Welcome to Ask Les. My name is Les. We had a customer with an interesting situation. He was utilizing a European-made air amplifying nozzle of a star-shaped design similar to what we have here. There are a few companies making this design. And he had replaced the European nozzle with an American-made one because it was a slightly lower price. However, it didn't perform very well. So he was a little hesitant to try this other one. But when he tried the next flow one, it worked as well and maybe even a little bit better than the previous European one. But why? Why the differences? So we have an idea as to what caused this situation. The way an air amplifying nozzle works is you have compressed air going through the nozzle, and its aerodynamic design acts in such a way to entrain air from the surroundings, mixing with the air coming out, amplifying the airflow. What happens when you put compressed air through a pipe is you're going to have some pressure losses. So let's assume that the customer had, say, a 1 meter long pipe. He was using a 1/4 inch nozzle, so it would be a 1/4 inch pipe. If you put in a certain amount of compressed air, as the air travels along, you will have a pressure drop. So even though you may have, say, 80 pounds of pressure going into the pipe, you may only have 75 pounds of pressure at the point of the nozzle. The higher the airflow through that pipe, the larger the pressure drop, and the lower the pressure will actually be at that nozzle. So let's now look at the figures provided by the different manufacturers of these nozzles. This is the published performance for the American nozzle, the European one, and for the next flow nozzle. The American nozzle had a published performance figures of 14 SCFM, providing 13 ounces of force at 12 inches away from the nozzle. The European manufacturer published 11 CFM, providing 13 ounces of force at about, I believe it was 8 inches from the nozzle. But whether it's 8 or 12, it wouldn't make that much of a difference in the force figure. Next Flow had published figures of 15.5 SCFM, providing 15 ounces of force at 12 inches away. Now, the problem we have is that every manufacturer is going to have a different type of test apparatus. Compressed air tends to be a bit of a fickle type of technology to test. So really the most realistic way is to actually retest these different products under exactly the same conditions. So we did this. Utilizing our particular test setup, our measured performance under the same conditions, because one was tested right after the other, measured performance at 80 psi or 5.5 bar under the same conditions. The American-made nozzle utilized 17 SCFM and provided 13.4 ounces of force at 12 inches away from the nozzle. The European nozzle utilized 16 CFM and provided 13.4 ounces of force. So you can see here the possible cause of the difference in performance. If the pressure drop was even a couple pounds, because the American nozzle used 1 CFM more, it's going to have a little bit less force than the European one, even though at the same distance under test conditions they provided the same force. But that 1 CFM made a very big difference. And the next flow one utilized only 15.5 CFM and provided 15 ounces of force under that condition. So you can imagine when they hooked up the next flow one, you actually got more force than you needed. So the customer can actually cut back the pressure a little bit if he only needs the 13.4 ounces of force. Maybe only use 15 or even 14 SCFM, saving even more energy. The other thing that happens when you cut back the pressure is you lower the noise levels. So you get both the benefit of extra energy saving and lower noise levels. What was interesting is that the next flow design provided the highest force per CFM. In other words, the best force per CFM ratio. And that's why we have a happy face. So that could explain what may have happened. What do we learn from this? What's the lesson? If you've never used air amplifying nozzles before, get a nozzle from every manufacturer. Just test them all. Hook them up to your line, have a flow meter on it, measure the airflow, and put a weigh scale and just blow against the scale and see how much force you get, or test it in your real application. And whichever one performs best with the lowest energy cost, weigh that against the pricing, and you have your decision. So, if you have any other questions, ask less.